For those who are curious or you're the first time here, I'm checking if I'm live or not because I always inevitably miss up a setting or the other. So there'll be 15 seconds of awkward silence. Awesome. I can hear myself, and we already have a few people. I'll take my headphones off because I'm not interviewing anyone today. Hey everybody, thanks for joining the Kaggle study group. I'm first of all excited to bring back the study groups. I was taking a break while switching roles. I'm super excited to be back, super excited to be learning with everyone. Thanks for your interest. I'll share my screen and get started and give everyone the context. So if you're joining my study group for the first time or any of our study group, welcome. Thanks for joining. For this one in particular, for today, we'll be going through feedback prizes, older competitions, top solution. The plan is to go through solutions from top teams. And if you've ever competed in Kaggle, or if you've not, I invite you to. If you've competed, you would know that there are always these tricks that you can learn. And the idea is to walk away with some learnings. Now, one small disclaimer: I am doing a machine learning study group, so these improve with time with your feedback. Don't expect the first one to be good, but I'll try to improve them. So your feedback is of course welcomed. Um, for today, we'll be going through feedback prize evaluating student writing competition. This was completed 5 months ago, and we have another feedback competition happening right now, so it might be relevant to that. I have already scheduled the one for next week, so if you just literally scroll down in the channel, you can see that this should be scheduled for the next Sunday. So the agenda will be every Sunday at 8 a.m. Pacific or 8:30 p.m. IST. We'll meet to go through these solutions. I'll try to explain the competition and spend most of my time reading the goal solutions. Rahul's asking if this is getting recorded. Yes, this will remain up on the channel, so you can watch it later in 2x speed also if you'd like. And hello to everyone who's saying hi in the chat. Great to see you, Vadim and Crowdog. Always great to see you guys in the chat. I'll switch over to feedback competition and start going through it now. But before that, I have a small announcement. Let me quickly pick the right screen to share. So as you might know, I've recently joined H2O.ai and I'm super excited to be helping with the community. We'll be launching a forum or of some format of a community really soon. You're welcome to join or provide your feedback. So if you just scan the QR code, this should take you there. And the idea is to basically share more knowledge with you, give you more resources to learn, and hopefully also connect you with our team of Kaggle Grandmasters. We have 25 Kaggle Grandmasters, including many that are in the top 10 of competitions. And the idea is to share that knowledge with the world. H2O.ai's mission is democratizing AI, and this is literally a part of that. Let me move back to the screen. This always takes a second. Awesome. Um, I'll come back to this later, and now let me start with the competition. So this competition had a really interesting problem statement. The organizers from Georgia State University state that why it's challenging for people with different backgrounds or younger students to work with automated grading systems from the perspective of instructors. The idea is to provide a solution or a machine learning model that can give the students valuable feedback, and this will be an automated system so you can then effectively teach more people. They give some stats about that students from different backgrounds don't have the most proficient English, and the goal is to potentially help these students. So it's for a social good. Potentially you burn GPU credits on social good. That's always a good excuse to buy more of these, and I'll keep using that for myself as well. So let's take a look at the example from the description page. Again, let me put this link in the chat as well for anyone. Highlight that. So it's literally feedback prize 2021 competition. That's the link. But you'll have a lead in a paragraph. So you have different paragraphs in English. and you'll have a lead that would provide some context or a statement, and then you'll have a follow up element. Now you need to identify this as what does it really classify to, and what are the different options between which you can classify it into. Let's see if I remember all of them. So these are the different options: lead, position, claim, counterclaim, rebuttal, evidence, or concluding statement. Now, why is this a difficult problem? I'll point everyone to this, and let me minimize that and this as well. I'll let you all read this for a second. So please, believe me, it's worth it. Give this 20 seconds of your time. So this is from a student, possibly a young student. So their answer is next paragraph. Wow. So I guess if we don't have cars, we don't have money or something. This is so boring. Twinkle, twinkle, little star. How I wonder what you are. And it goes on, and it ends with a bye bye, love you, mic drop. Somehow they managed to get my get my answer as a student. I'm pretty sure I would have written this if I was a student, but I don't know. I found that really. That's an outlier, of course. That's a really good example to get started with. But these are the types of examples that you also need to grade through. This is an outlier usually, but with students, you can see there are spelling mistakes as well. There is switching of context. So, how do you go through these? How do you create a model that can effectively decide if the student is giving the correct follow up to a paragraph? So, the dataset that we have has been annotated by experts, and it's been a team of experts. They've really taken care of it. You can go through the description page if you like. You can learn about that. And there are about quite a few examples. One thing I learned the hard way with the recent competition: 100 MBs of NLP data actually means a lot. That translates to a lot of computers. But let's just open up any example from the training data set. So this one looks like it's an example of distance learning, and there's some statement about distance learning, and I assume the student would have followed up with the fact that they can't meet their friends, and then you can say it's a counterclaim. So your goal is to check if through a machine learning model that it's a counterclaim, and you have been provided labels by expert, and your answer needs to be matched with those. How do you get scored on this? Let's go to the evaluation tab. If you read through this, it sounds like IOU at first, but then you scroll down and you realize it's a macro F1 score. So they're using macro F1 score to evaluate your predictions. Inside of the data, you've been provided with these wonderful paragraphs like like this. I've been obsessed with that example. I've read it a few times. I've already shared it with people. Hey, this is what Kaggle is like. They didn't get interested, but I tried. Um, you have those paragraphs, individual TXT files. Then inside of a training CSV, you have the annotated version of all essays where you have the IDs, the discourse ID. You have the character position where the discourse element starts, where it ends, and then also the text of discourse element and the classification of discourse element. So the label essentially. And in your submission, you basically need to provide the ID, the class, and the string. So it's somewhat of a text token classification problem, if you may. Now let's head over to a few more examples. I was going through the solutions, trying to understand how is this a challenging problem. Also, I forgot to totally mention this, but I got a lot of help from one of my wonderful teammates, Crowdog, in understanding a few of these solutions. So he's an absolute king in NLP competitions and other thing, and also Nishchay. So for the good parts of this study group, they're coming from them, and the mess ups are probably from me. So thanks for your help, guys. Uh, They also performed really well in this competition. But now I'm trying to set up the problem statement and tell you all why was this a challenging problem. Going through all of these discussions, I plan to quickly give you the context and then I'll jump into into the solutions. This is the planned way, but I welcome your feedback for the future ones. Um, Jay-Z is a Kaggle master, but he's really great at NLP competition. So every time you see him on the leaderboard, just assume you lose one gold, subtract one gold from the open gold positions because he'll probably land there. Um, he basically wrote about this while I assume the competition was going on, that the models aren't converging, and they kept training this, and people had this discussion as well. Apparently you had to pause the model training, restart it with the saved weights, and that helped it a bit. So these are all of these little weird tricks that you understand while just going through different problems. This is where the real secret lies, I believe. Like if you're working on a similar problem and you see the exact same thing happening, just pause your model training, restart it with the saved weights, load them again, essentially just restart the training. uh, Furthermore, Darek Kwechik, he's also an amazing Kaggler, I believe soon to be a Kaggle grandmaster. He wrote this post. You can go through it. I'll just give you the summary that he was really struggling to come up with a baseline and understand everything. Then he realized he didn't set up the splits the right way. And then one of the Kaggle legends, Chris Stewart, also agreed to this. So it's quite a tough problem. We need to summarize it really fast, but that doesn't make it any easy. Abhishek Thakur had a wonderful kernel teaching you how to create splits. Let me see if I can find that. You can go through this to understand what's the optimal way to create folds. This was really one of the popular notebooks, but I'll skip this. Just pointing you towards this to learn how to properly set up K-fold validation for this competition. With that, I'll start going through the solutions, and I'll start with the most exotic one first. But I have one more piece of info to give you all. So, Chris Diot had again written this wonderful post, very explained, named entity recognition. So, I've set up the problem statement, and I'll quickly explain what's one of the approaches. I'm just reading this. Chris explained it. I'm re-explaining it to you guys. I don't get credit. So NER stands for named entity recognition. It's text token classification. And this is a wonderful analogy. So think of NER like being image segmentation when it comes to text. Question answering is like image detection. And initially he said both segmentation and detection can help in this case. I gave a bit of teaser. Someone literally created a YOLO like text span detector. And the top comment there was this solution should be number one, which many of the people agreed with, at least 13 of them. We'll come back to that, but someone literally had this very innovative ideas, and that's what we're trying to learn here. That's what I'm actually trying to discuss here in these study groups. So with this analogy, with image segmentation, you assign each pixel to a class. So let's say you're trying to classify me. This will become a GPU. This will become chai noob. That becomes a monitor. You literally label every single pixel. And when you're doing detection, there'll be a bounding box around me saying chai noob, proton super. That's the name of my box, and monitors. Quick refresher on image segmentation and detection in case you forgot, although I don't think anyone did. So drawing that analogy to NLP, when doing named entity recognition, each word or token gets assigned to a class. Now, if you are forgetting about how do tokenizers work, I should probably just Google this. The Hugging Face documentation is really great, and they also have this in their, I believe, course, which really covers all three forms of tokenization: byte pair encoding, word by word, and I believe it's the third one is sentence tokenization. I would encourage you to go through the docs. if you need a refresher for that. Let me find the correct tab without going to the leaderboard. I always mess up with with the zoomed in screen. So coming back to this discussion again, when doing named entity recognition, each word or token is every single character being passed inside the model, it gets assigned to a class. So like how in segmentation you have every single pixel being assigned to a class, it's the same for NER. And Vadim corrected me, it's sentence piece tokenization. Thanks, Vadim. Vadim is a young Kaggler from Ukraine and he's much smarter than me, as you can see. Thanks, Vadim. For detection, we find boxes in image instead of irregular shapes. And we find boxes in text similarly. Boxes have the advantage of capturing holes, that is pixel or words, that may be in the middle of the area that segmentation may overlook. Now, if you'd like, I would encourage you to go through these notebooks. The code is from a quadruple grandmaster and you can learn through it. But just wanted to give you that context. And there's another tutorial by again Chris, which I'll go through. So here he basically teaches you how tokenization happens. What is the difference between characters, tokens, and word? Let's say you input the sentence, hello, my name is Chris Diot, how are you? These will be the tokens that are created. And with different forms of tokenization, I believe you can end up with different representation inside of the model. So you have 44 characters that become 13 tokens and 9 words. And then further, you can learn how to convert between these. So in this competition, Kaggle labels as characters or words. So therefore, we need to convert these labels to token labels. And the easiest way is to do that via character array. I'll just let you go through this to understand through the image. And then further for training, you can convert characters to tokens that essentially need to be passed to the model. You can read through this, but this is all I wanted to cover. Again, the idea here is you have all of these models. Any Kaggle would probably default to Deberta small as a baseline. Would you use Deberta large for a baseline, Deberta extra large? I don't know. Deberta is king for Kaggle competitions. That was also the name of some team, I think. But what pre-processing, if you may, do you need to apply to your data, or what tokenization approach do you need to apply while passing that data to your model, and how do you set that up? That's where all of this is relevant. So that's why this context was somewhat relevant, in my opinion. With all of these tutorials, I'll start going through the sixth position solution first. My biased opinion, this was sixth. First one is definitely objectively better, but this was quite innovative. So let's start with this. So the sixth position solution uses a YOLO-like text span detector. And heads up, the code is available, I think, on GitHub. Yep, they have shared their code on GitHub. And I'll prove that they're using image techniques, because if you go down here, you can see that they're importing from Torch Vision inside an NLP problem. So they're using cross-domain knowledge to solve this, which is quite innovative, if I may. And they're also using MMCV, which is a really popular computer vision module. You can go through their code if you like. They have on their GitHub stochastic weighted averaging and their training script available, as well as their prepare fold script. I won't go through that. It's quite easy to understand. So they say they completely ignored the shared NER baselines and they thought of this as an object detection task. I wonder if that discussion module was was the reason for them to start that way. But that's the origin for their solution, they say. And inside of the modeling network, uh, they have two different techniques. So one is for objectness. Remember the one we just saw, which is span, where we create these boxes, and the other one is for regression, distance of location to first and last index of the corresponding span. Span again is, let's say you want to classify this as a rebuttal. So this would be the span of the entire sentence. A number of classes for discourse type. So they aggregate tokens to words because network logics has this shape and they say it's inconvenient. So they decide to aggregate it using ROI align. Now, what is ROI align? I would recommend Torch Docs, Torch Vision Docs. But that answer is actually what it will eventually lead you to. So this defines the. This is not helpful at all. I wonder if I landed on a different page earlier this morning. No, maybe the first one. That's not helpful. Sorry about that. Um, I'm confusing myself. I'd seen something more relevant in the docs. But anyways, if I go back in my search, it's region of interest align, and it's an operation for extracting a small feature map from each ROI in detection and segmentation based tasks. So you're essentially extracting individual areas of interest from, let's say, inside this box, if you can see my mouse hover over it, and properly align them with the input. I assume this makes your model understand the exact span better for this case. That's my intuition. I didn't participate in this competition. That's why I'm trying to draw analogies. Then they say the problem of this formulation for objectness. Again, they're drawing analogies. The first way of modeling for them is objectness, and the other one is regression. The problem is how to define positive for objectness training, because in object detection images, the center of the image becomes a natural choice. So through experimentation, they found that the first word of a span, let's say if this is your span, in would be a good choice of positive. And they assign lowest cost word in each span as positive during training. If you go through the YOLO X implementation, this would make a bit more sense. Vadim says, analogy with object detection, we can cut some regions and the bounding box can see what object is there. Thanks, Vadim. I believe, Vadim, you had also taken part in this competition, if I wasn't wrong. Maybe you were just sharing insights. Now, how do you perform augmentation for such a process? There are a few ways of performing text augmentation. There is one really popular paper that I'll point everyone to, and also a framework. But back translation is one of those. So you take a sentence in English and you use an open API, I don't know, some translation API, or maybe you use a model. So you take your sentence in English, you translate it to a foreign language and translate it back. So that's back translation. And the fine differences that happen in this duration help your model. It's different enough for your model to improve a bit. One of the top solutions said they actually tried this and it wasn't helpful. So I'm not sure if that was just for them, but maybe for this competition, at least for that one team, it wasn't helpful. We'll come to that solution afterwards. That's one of the augmentation. But they say here they randomly replace tokens with mask. So they do mask augmentation, which means basically they delete a few words randomly here and there. And for post processing, they use, I think this is non maximum suppression. I might be messing up on this, so I'll again search for NMS and Torch Vision Docs. Non-maximus suppression. I take my earlier words back. On the boxes, according to the IOU, NMS iteratively removes lower scoring boxes which have a score IOU greater than the IOU threshold. You can go through, I think this was in the Mask RCNN paper, but you can go through that to understand. Vadim says he didn't participate in this competition. He was doing NBME at that time. That's great. Maybe when I'm presenting NBME, I'll invite you to help me. Um, he has an example for mask augmentation. So you basically put a mask instead of hello world in this example, as you can see. And it's similar to MLM pre-training. Thanks, Vadim. Then they talk about they used a one cycle policy for training and they averaged weights of the last few epochs. We saw SWA, which is stochastic weighted averaging. I think I at least know this acronym properly. I'm a podcaster, guys. I'm not a I'm not a stats expert, so I need to Google these. Um, Dinesh says so. Basically, NMS that is less frequent boxes are removed. For images, yes, that's how it's helpful for removing boxes that aren't. From my understanding, it's like if a detected box from a model isn't very confident, you iteratively remove that, and it's somewhat similar to that. Please feel free to correct me if that's not accurate. And then they ensemble different models or folds. They simply average outputs of models. For them, weighted box fusion. I'll tell you all what this is because the second place solution had this. But weighted box fusion ensemble does not work in local CV and they didn't try it further. Furthermore, they share their validation and public private scores. Uh, I won't go through this because if you are in the heat of the competition, these are relevant. Afterwards, you just look at the position and you don't understand how much of a effort it took, let's say, to, I don't know, go from 0.71 to 0.75. Where would 0.71 be here? Somewhere around here. So in a difference of third digit decimals, you jump what 100 positions, maybe more than that. Yep, more than 100 positions. I'm trying to romanticize Kaggle competitions because I really want to invite you all to take part. um, okay, let's come to the serial order now I'll go to the first position code. Let me quickly take a sip of water while I do that. Any questions in the meantime, or any things that I might have missed that might be of interest? Doesn't seem like it, so I'll continue. The chart always takes 1 minute to come in and then I have to go back. I'll do that. um so this person, how do you pronounce this username? I can't. um this Kaggle grandmaster finished first. I think their team might have. Yep, it was a team solution with a really good name. They finished first with a LB 0.742 and CV slightly higher. And you can go through all of the resources that were discussed. I just covered the ones that were important here. So they say they tried various pre-trained models, and inside of different models, this is again some more context that's relevant. So Deberta has, I think, a max length of 512. I might be wrong. Roberta has a max length of 512. Some models have more than that. In this competition, people discussed how you can use different models for longer lengths. Now, this is again one of the hyperparameters that you can decide how do you end up passing it to a model. So while you're training your data, while you're training your model, you pass this text to the model, right? And you can't load all of it because it's a lot of examples. If you're using a transformer model, you're already possibly using gradient accumulation and you will run out of memory really fast if you go to really good length. But when you say it's 512, you decide to pass in 512 characters or tokens at a time to the model. For this person, this is since the max length of some models, Arvind has corrected me. We can pass more uh, length to Debota beyond 512. Thanks, Arvind. But since some of the models here have a max length of 512, they choose the method of segmented prediction and splicing. And finally, they have a choice of a long form or large. So they're talking about their final ensemble. I believe they ended up using the following models. Why are they talking about time limits? Inside of different competitions, there are different constraints. Kaggle doesn't want you to create a 5,000 model ensemble. So they limit you to 9 hours of CPU and GPU runtime, and they don't release the test set to you. So that's it's secretly scored inside of a kernel, and you have to make sure it runs under 9 hours on the GPUs provided in Kaggle kernels, which I can tell you are slightly, actually quite a bit slower than uh, 3090s at least. So coming back to this stage one, which is BERT-like token prediction, uh, they talk about all of these models they had set up a five-fold CV and averaged it, and they highlight their best performing models. So they even managed to get 4096 length on a long former large and base as well. As you can see, large performs quite a bit better. Again, for Kaggle competitions, second digit decimals are quite relevant. In the real world, not so much. So this is not a slight difference. I can't critique this. When I'm reading a paper, I will, not for Kaggle. I'm biased. Um, they've open sourced their course, their code, and you can go through it. But here's how they train the models. After that, they create second stage models, and they use a LGB model for sentence prediction. So Crodoc had helped me understand this a bit. Thanks, Crodoc. There's also a reference notebook, which I opened and I got so terrified, I called Crodoc to explain this to me. They say they recall as many candidate samples by lowering a threshold. If you set the threshold to 100%, you'll get all of the candidates, but you'll also get negative candidates. So we just want the positive candidates here. And they recall 3 million samples to achieve a mean of 95% recalls. They share the recalls for different classes. Then out of these, they make 170 features for a LGB training model. And with this post processing, they jump from 0.697, which I don't even want to scroll down on the leaderboard to. So I would imagine they had a really awesome jump. But with this post processing, they jumped really higher up in the um, leaderboard. So why is this post processing relevant? When you have all of these models giving you outputs, you can pull these outputs out through different ways. You could use their embeddings and play around with that. You could use their candidates, like this case, build meta features on top of them, run a LGB model like they have, and get even closer accuracy to the real predictions. So the LGB model with those meta features, so you train your text classifier. I'm trying to find my pen. Give me 1 second. Go to draw. I'm feeling red color today, so I'll draw with red. So you have your input, which is passed to your different models. Let's say, I don't know. Also, look at this handwriting. It's an absolute piece of art. Let's say this is a 4096 base long former. This gives out some predictions. But before that predictions, you could also use the embeddings from inside the model, which help it generate these predictions. and you could extract or create models on top of it, or you could use these predictions from different models. So let's say, I don't know, you have an ensemble of different models, model 1, 2, 3. Out of all of these, you create some meta 170 features and you run a light boost or a LGB model on top of it, which gives you predictions. So this is the post processing that's happening. It's called post processing because after your model is trained, you take the outputs and create a model that processes them further. For some competitions, and this one in particular, as you can see, it provides a huge boost. That's where this is relevant. Let me quickly catch up on the chart. Nishchay has answered Arvind's question, but I'll still highlight it. Thanks, Nishchay. What if we use MLM pre-trained and make predictions on validation set and use that as a new point? I think that's pseudo labeling of some sorts. I think that is pseudo labeling. Nishchay says that's a pre-training step. It's better to generate predictions from fine-tuned models specific to the problem statement. So you essentially, I see what Nishchay trying to say. Uh, Nishchay is suggesting you take your model first, you're pre-trained. I'm trying to think of a model. Let's call this Big Bird. So now you use Big Bird and you fine tune it on your trained data, which are all of these different TXT files, and then you classify the final validation set. I think you could also try pseudo labeling. I'm not sure how helpful that would be for this case. Next, they talk about things that were helpful. So they used adversarial training, which you can think of as a form of regularization. So you add adversarial examples to make your model more robust inside training. They say AWP and FGM were helpful. You can look these techniques up. These have been used in a lot of solutions. I've read about them in a lot of solutions, so I won't go through them in detail. They say model ensembling was helpful. As you can see, this is not a small difference. This is quite a significant difference. And then they say the post processing was really helpful. Things that weren't helpful, I just spoke about back translation. Remember translating from one language to a foreign one and back to the original? That wasn't helpful for the first position for this competition data set. They tried. And adjusting weight according to the position of a sentence in which word is located, that didn't help as well. That's all I wanted to cover in the top solution. Any questions with regard to this? Their code is open source as well. I encourage everyone to go through it. And also, please remember to upvote any winner solutions or any things you enjoyed reading. It encourages Kagglers. Any questions with regard to this? I'm out of chai already and I'm running out of water. But now I'll move on to the second position solution. Um, I managed to find it finally. I will open the leaderboard in another tab because why not? So this was a team of three Kagglers. Chun Mingli, who is a Kaggle Grandmaster on the H2O AI team. Uddhav Bamba, who's a Kaggler from India. Great uh, to see him always. I've trolled him a few times on Twitter, so those are my best memories of interacting with him. And Chris Diot. So we'll be going through their team's solution, and I believe this is where Chunming reached the Kaggle Grandmaster status. I think they got their fifth gold medal through this competition. But let's go through their solution, and I'll first scroll down because weighted bear box fusion is explained really well here. Um, I'm trying to find where this was explained in an older competition. Let me see if I can find that. So not this. This refers to the code, but I'm trying to go to the TensorFlow GBR competition where this was explained. Let's see if I can find that in real time. Hmm. Yep, found it. And this was shared by Chris again, if I remember correctly. He was somewhere around the 60th position, I think. So I need to know his position to look look that up. 69th position. I need to explain weighted box fusion. That's why I need this. Uh, I remember reading about it somewhere, and yes, this was a post. Sorry about that. So if you have a tenfold model, this is an example of computer vision, but please bear with me. So if you have a tenfold model and each model is inferred with a box having a confidence of zero point 0.1, we apply weighted box fusion. It is possible that three models find a starfish with the following confidences, and the other seven models do not find that box. So in this case, the average confidence becomes like so, and we need to remove this box if we don't wish to have boxes under confidence zero point 0.1. So where half of your models aren't confident about the prediction, but you still get, sorry, if you want to keep this model because some of them think there's a starfish and some don't, you would apply a weighted box fusion. So you would average all of these, or you would filter out some of these, like so. So you set a confidence zero point 0.1, let's say, and you go through all of these boxes that have been predicted. And if their score is less than the decided score, you append them to your filtered boxes list. And using this, you can get a good boost. So they managed to use this technique inside of NLP problem. Again, CV problem, CV approach being applied to NLP. Let's start reading this from the top. The secret sauce was powerful post processing by Grandmaster Chunming and having a huge variety of models. They used weighted box fusion, which I just explained. The link was right here. I was trying to recall if this was linked somewhere, but uh, I still stumbled anyways. As you can see, this is live and I can improve a bit further. Sorry about that. So they trained a bunch of models. I'm sure they trained more than these, but these are the ones they mentioned. Deberta large. I'm naming these because whenever you want to go back to NLP competition, I would start with these. I would start with the models that the top teams had used as a baseline. If you, and I really hope so, if you go back or go to the newer feedback competition, start with these approaches. That's the reason why I'm hosting these study groups. So let's see which had the highest score. Deberta large. I would have thought Deberta V3 large would have had higher score. I'm surprised by that. Deberta V2 extra large scores lower than Deberta large. Interesting. Um, so Deberta large had the highest score. Interesting. Not the V3 large for some reason. Again, I would be tempted to try the latest iteration of the model, and apparently, trying the older one is also a good idea. And with these also they made some augmentation. So they added a LSTM on top of the outputs. For some they added a LSTM head. They converted a Roberta from 512 to 1536 and had a few variations in all of these. So their final solution had all of these 10 models, and they included 3 out of 10K folds for each of the 10 models. So all 10 models were trained on, I believe, 10 folds, and they included 3 out of these 10 folds models created. And this was, I assume, done because their submission time was 8.5 hours, which is really close to the limit. Further, they used weighted box fusion to combine these predictions. And this, as you can see, caused a really nice jump. So let's say you have two predictions. The model one says, this is the span or this is the box that you should be looking at. Arvind is asking, how can we ensemble this many big models? Well, that's your answer. You don't have them from, you don't use all of the folds or all of the models trained on every single fold. You have to settle on a few. So I assume they filtered out the best ones and tried this. Again, these are the fine details that you learn by competing, right? Like if you just read this, you know they're ensembled 10 different models. But which ones did they select? How did they select that? And how did they perform that? That you can only learn by replicating it yourself. That I think is the secret sauce. The leaderboard is the secret sauce. Um, so how do you combine these two predictions, or how do you average between them? Weighted box fusion would essentially, as you can see, somewhat average between these two predictions. So let's say one model has this string 8, 9, 10, 11, and the other one has 10, 11, 12, 13. WBF takes the average of the two starts and ends, resulting in this span. That's how they set this up. Furthermore, they explained how you can average it for different approaches and why is that not helpful. Next, they talk about post processing, which was their secret sauce as they described. So they say they applied heavy post processing to word level soft predictions each model made after averaging token probabilities across fold. So they take I assume the probabilities coming out of every model after averaging across folds and before applying the weighted box fusion. They repair span predictions. So they say since they use cross entropy loss at token level, there would be some broken spans. So I would assume like let's say this is your predicted span and then there's a breakage in between and your detected area continues. So they created a rule that essentially marks this back to the predicted label again, which kind of makes sense, right? Like if this part is like a disagreement statement, somewhere in between you wouldn't have some other label. So that's actually really smart. That makes sense. And I assume they uh, landed on this by actually looking through what the predictions were. Next, discourse specific rules. They came up with common sense of heuristics for discourses. For example, lead, position, and concluding statements. There should be only a maximum of one each for a text, which makes sense, right? Like if you have an answer, your model might predict that this statement agrees and disagrees. That's not possible in a single paragraph. You can't agree and disagree in the same sentence, right? So you apply some heuristic, see which model has a higher confidence, and based on that you decide. I assume that's how they applied it. That was a heuristic. And next they adjust the lengths of predicted spans. So they say, for example, if a predicted evidence span has less than 45 words, that shift the start back by 9 words. And this was really key for their case. Next, they share some details about how they use the models and how they trained it. I think I'll skip these because these are really straightforward. And the inference code and training code has been made public. So I would encourage everyone to go through these and remember to upload the solution if you liked it. I will close the irrelevant tabs again and come to, let's read the third place solution. I think Darek Kwechek was part of the team. Yes, along with Shujun and Amit. So this is a nice overview of their solution. They used long former and Deberta extra large, which predict candidate spans with features. They use these features, feed that into GBM models, and get the final predictions. So they as well used a second stage model. That's why I started with the sixth place solution. It's like you can see the top teams had somewhat of a similar solution. Of course, there are finer details, but the sixth position was really different. That's why I think it was quite innovative. This is really technical stuff. That's how you find, you can call that solution sexy, but it's really technical jargon, and you have to appreciate something innovative. Uh, Even though I probably won't be able to re-implement it just by myself. So now I want to talk about the sliding window approach that they had used. So think of it similar to how you train a CNN. Earlier, I'd spoken about how do you feed smaller batches to a model, or smaller um, spans, right? So 512 or whatnot. For this case, let's say this is your first window, and then you slide it a bit and feed the next window like so. So this would go up to instead, I would assume. And then furthermore, this is an example, it varies a bit. So you slide it by, in this case, I think 64 tokens every time. So your model sees every word a few times, I believe. This is how, at least for the Deberta Excel, this is how they input the tokens. You can go through the code to understand this, and towards the end, uh, they concat all segments and run it through two-layer GRU as well. And then they use two forms of augmentation. They mask 15% of tokens during training and cut mix. Again, more image analogy, but similar how to cut mix works for images. They cut a portion of one sequence and paste it and its labels into another sequence. So I have a really fascinating way to showcase this. Let me see if I can find that real quickly. Give me 1 second to visually remind everyone of how cut mix works. Sorry about that. Just give me 1 second, please. I'm trying to find the correct example. Yes, I found it. Sorry about that, guys. Um, Let me switch screen sharing and share a different screen real quick. So I'll use hydrogen torch, which I originally wanted to demo as well for this talk and showcase how you can solve different problems here. Uh, This is a no-code solution by our team. I say our H2AI's Kaggle Grandmaster team, uh, and it has their secret sauces to help you use AutoML to create deep learning models. Uh, you can create text model inside of it. As you can see, I tried feedback competition, but this was last minute engineering and not quite ready to present. So I'll just explain cut mix here. Sorry, I'm explaining mix up and then I'll explain cut mix. This is a really nice example of how you do mix up. So as you can see, two images are somewhat being put on top of each other. That is mix up. And cut mix is if I would cut a bit of this image and paste it into another. That's cut mix. So those are the two similar, slightly different form of augmentations that you can apply. Let me. You can read more about hydrogen torch. This is not a product pitch. You can find about it on S2A's website if you'd like. I wanted to utilize that opportunity to showcase my bosses that yes, I do use and try training models there. Um, so they cut mix different words into each other, and I'm trying to see if there's any other interesting bit that I want to mention here. I think I'll skip the remaining here because it's quite straightforward, and I would request everyone to read through this. So that's the quick summary of the third position as well. I spent more time on the first few solutions because that gives you more context, and later on, you can see that it gets similar really fast. So it's better for me to quickly sift through. I will probably only go through a few of the top solutions and not all of them. Vadim, who I'm not sure if still he's in the chat, but he had created this really nice summary of all of the top solutions. So I would request everyone to go through this if you'd like to catch up on all of the examples. Um, it's titled Solutions Write Up. That has the summaries. Let's see, after the third one, I can come to the fourth. So they share an interesting approach here, which teaches at least me to look inside how tokenizers work. So when you feed data to your model, you can use different tokenization approaches, as you discussed earlier. If you look inside the tokenizer, you will be terrified to death, and you'll probably be scared to continue with NLP. You should, because they did, and they found out that there were some interesting things appearing here. So they fixed that by actually going through different encodings and trying to fix these like so. You can go through this code. I'm just giving the quick summary here. Next, they talk about should you use word IDs or offset mapping. NER examples use word IDs, but they tried this for labeling subword tags as well. And they tried a different approach which requires you to return offsets to make subword NER tags. And they said this provided a slight boost. They realized, sorry, I think it was slightly hurtful. I'm confused. They say to make this work effectively, you need to split and prune the line break because this fixes the issues inside the tokenizer. After this, they share about their beam search approach, which I'll again skip here. And they performed a entity level ensemble. I'm just reading through the headlines because I think I just want to give the quick summaries from here. So the quick takeaways were you should look at abnormal characters and try to fix that. And also try to pre-process your data set. Sometimes just removing extra lines can be really helpful, or just looking at how that helps your model change its performance might change things. So I can close this tab as well. I think this is the last solution I'll quickly cover. So they say Deberta is king, pure ensemble of bird models. That's the title. Jay-Z is, I hope I'm not mispronouncing their name. They are a NLP king. So anytime you see them on the leaderboard, you can be sure that they are going to occupy a gold position. Um, they tried to use recall of different models to do re-rank LGB, similar to how we just read. So remember, recalling the candidates and creating an ensemble, not ensemble, second stage model. Apologies. So they say their best single model was Deberta V3 large. I'm happy because I thought Deberta V2 large was outperforming for this case. Maybe it was the other team's training setting, but at least for the ninth position, it's better. That makes me happy because I like this model. Um, and a max length of 1536 single model could get them private LB 718. They tried long formers as well, but they say short former with a slightly shorter text span. Actually, half of it is better. Now they say what improved the single model performance. They claim be sure not to remove the new line. It's a super important feature, and they changed this to break to make sure all models like tokenizers can handle it correctly. I assume some tokenizers would just remove it, so they made sure it's fed to the model, and on they create a word level LSTM on top of BERT, which helped it further. Then they used this rule from the small code snippet. So if separate separator product probability predicted is greater than smaller separator probability, they set a flag to true. And if the sentence is long enough, they keep it true. So they are just filtering out longer sentences. And they also have a similar, I think they are eliminating gaps as well. But they say this could not beat LGB. So as you can see, this is also similar to the second place solution that we had just read a while ago. Finally, they ensemble all of these models, and I'll skip these details as well. I believe that's all I wanted to cover from this solution as well. Let's see if I missed anything. So we went through the first position solution, the second position, third, fourth, sixth, and ninth. I'll, as a homework, leave other solutions to you to understand and quickly summarize what we've gone through so far. We saw that Diverta V3L is king for a few people. We learned about the sliding window approach. We learned about different ways of tokenization. We saw a few innovations bridging across computer vision to NLP, how you can utilize those. And then we saw a lot of post processing being really helpful for this competition. It gave huge boosts. And then also simple post processing, right, from the second position team. They say it's not sexy or eye popping, but I think it's really interesting, right? Because they literally looked at the model outputs and came up with some really good rules. So you need to sometimes handhold your model like that. I really like that example which eliminated a gap. Or if you have two classes being predicted in an answer between two different models, that's just not possible for a few of those, right? So just common sense can also be really helpful. Basically, look at what's going inside your model. That was from another approach. Fix the encoding. Look at what's coming out of it. Come up with a few heuristics. Come up with innovative ideas from computer vision if you can. uh, I'm sure many of you can. I'm just challenging myself. Um, and Deborta V3 LS King. I like that model. Arvind is asking a question. If we ensemble knowledge distillation versions of models, will score be the same because we can ensemble more models? LB is the truth. You need to try and do that. Which brings me to giving a few suggested homeworks. I'll speak about this afterwards, but I would request you to join the new feedback competition or make 5 late submissions to the one we just discussed, or join the AI for code competition, which is also an NLP one. It has 4 days remaining. You're welcome to do that. I'm excited to kick off another 27 days series. So I don't like, I like to create a dent in the world. And I like 27 because my username is in it 27. So I invite everyone to join 27 days of Kaggle, where you Kaggle for 1 minute or the entire day for next 27 days. It can be 1,000 days, it can be 10,000 days. It's up to you, but 27 is the number. Write about it in a blog, tweet, or LinkedIn post. Share it with the world because this really helps act as a high signal filter and strengthens your understanding as well, in my opinion. And please consider sharing it, tagging me, and sharing it on different places on the internet. If you write a blog post or would like to share your approaches, I would love to invite you in our study group to present these. So for our next one, you head over to the channel. Um, I have already scheduled AI for code reading group. So this competition ends in 4 days. And next Sunday, we'll be going through these top solutions. So you can click the notify me if you'd like to be reminded of this. You're welcome to join that study group. And I forgot about this. I had interviewed the fifth position team, Ahmed and Crodog. So you can also consider watching that interview. But what I'd really encourage everyone to do is please consider spending more time on Kaggle. Again, thank you for joining this study group. We'll meet again next Sunday at the same time. I'll be live streaming. If you have any feedback, please scream at me. I'd love to improve this. This is for you, there's no other agenda. I'm screaming inside a closed room on Sunday just because I enjoy this. And if you have anything that can make this better for you, please let me know. Thanks for joining, everyone, and I'll see you next week. Trying to figure out how to end the live stream. That's taking a second. Awesome. I'll end this now. Thanks, everyone.